Looks like it's going further north of us than it was originally.
I think each run has been sort of farther north, yeah.
Just looking at the radar, it's almost as far north as Minneapolis.
Okay, welcome to Weather Watch today. Thanks for coming. Sort of the two big stories for today's discussion, although I'm not going to focus more on the latter of the two. One is later this week. This is midnight on Thursday. The GFS is forecasting 65 degrees, which probably means we're going to set a record Wednesday night, or Wednesday sometime, and perhaps start Thursday with a record high temperature. Again, midnight in December, 65 degrees Fahrenheit is something you don't often see. So we'll see what the factors are in that. You'll also notice conspicuously on this map at this time, it's pretty chilly up to the north. The reason for that, we'll look at a different model output, but it's pretty similar to some of the other ones. Here's the Ecws forecast for snowfall over the weekend. This is down 33 hours from this morning at 12Z. So this is by late afternoon tomorrow. About 1.9 inches of snow on the ground here in Madison, perhaps. But to the north, a much deeper snowpack begins to develop, with snowfall amounts on the order of, over half a foot to maybe close to 10 inches in some places. There's a band of heavy snow that sets up toward north. We'll look at that a little bit in some of the diagnostics that we'll be looking at. So first, we'll turn to the GOES imagery in the first tab, the visible imagery, and we can see a fairly expansive cloud shield associated with a baroclinic leaf cloud, warm conveyor belt type structure that's emerging from the southwestern part of the United States and advancing very rapidly toward the north and toward the east. You can also see a lot of cumuliform clouds that formed over parts of Louisiana and the southeastern part of the United States. And from sort of the orientation of those clouds, you can see sort of a indication of some moisture, water vapor streaming northward in this broad, warm sector-like area well to our southeast. We'll see dew points here are in the mid-60s, mid and upper 60s, so it's a very juicy, very moist system that's about to inundate us with the cold air that's in place, and we'll see what the implications of that are as we look at the forecast. Also, we'll note, I actually did not look at this, we go to the water vapor imagery as well.
I want to look at the day cloud type 1 too at some point.
On the water vapor imagery, just another form of IR, and I didn't get a chance to look at this carefully. Some neat little swirls here, these little wrapped up vortices there. We'll see if we see any indication of them in the, when we look at the wind aloft on the charts at 300 and 250 hectopascal. But these areas of dryness indicate areas of historic subsidence in the upper troposphere, lower stratosphere that occurred earlier. So these are some dry areas in the imagery. And you can also make out a fairly broad trough out of the southwestern United States. And some of this dry air is going to play a big role in shutting our precipitation down briefly overnight tonight before it begins to resume tomorrow. You'll see that in some of the forecasts. You don't look at a day-night imagery?
Day cloud
imagery?
Yeah.
Particularly night imagery.
Day night. Should be this one. So on this image, it's using different spectral bands from GOES east for the red, green, and blue channels of the image. So when you see the reds and the yellows, those are higher clouds. Green typically is snow on the ground. Lighter blue, like the cyan color, are lower clouds. And then the real kind of deep blue is land, and the black is water. So you can see, as Michael was saying, these are higher clouds. maybe some convection going on down in here, lower boundary layer convection that you can see down on the Gulf Coast, snow back through the mountains. Guess they had some satellite imagery earlier of Hawaii with snow on the volcano peaks.
And these clouds here, this band cloud here is for a fog bank that's developed over the upper Midwest, just south of the Great Lakes. And I guess they have dense fog advisories over those sections of the country this morning.
But I was just curious what that looked like.
Thanks, Pete. Yeah. So next we're going to go to the radar, please. I don't have that on that tab, so we have to search. National Radar, we'll go to Loop, composite radar. And again, you can see some steadier precipitation. This is more stratiform precipitation. We'll check to see how much of this is actually reaching the ground. With this nice band of precipitation that's already set up to our north, where we're expecting some of the grand totals of snowfall. And then this area of, some of this perhaps convection, but this other area of precipitation surging northward toward the southern part of, toward southern Wisconsin. And we're going to expect, we'll see in the forecast that precipitation will begin to break out over us sometime later this afternoon. But because of temperatures, which we'll see in a moment, that are going to be relatively mild, it will likely be in the form of rain at the beginning. Not much else to point out here on this map. Remember, this is the big game in town that we're going to be focused on. Next, let's look at our surface map for observation map. We'll start off in the upper Midwest over us. Wisconsin. Nice east wind with 30-degree temperature, 26 dew point. So our wet bulb temperature is certainly below freezing. We're getting precipitation now. Precipitation falling would evaporate. We get to the wet bulb. That's probably going to be below freezing. In Milwaukee, because of the effects of the lake, that's going to be above freezing. But we'll see that temperatures are expected to rise and moisture level, the dew points are going to be going up. So our wet bulb will be above freezing later on today. Biggest thing I think that's a factor when you're looking at precipitation, a big winter storm, two factors: it's going to be cold enough, is there going to be sufficient moisture, and then what are the forcing mechanisms that are going to be around, and put that in quotes, to produce the vertical motion that's going to be necessary to get us significant precipitation. First of all, these dew points down in Texas, in fact, in the low 70s, in fact, that's pretty juicy air for any weather event that we're going to get. As this area is moving northward. For this time of year, I think that's pretty impressive. Not unheard of by any standard, but certainly very impressive, the surge of these strong southerly winds transporting water vapor northward. That's one thing. You can also see these winds, as you move northward, there's a band of confluence that's set up. And around this region of confluence also, you see a lot of fog that's set up here. This is fog, this is haze. But you see there's confluence here, and there's a temperature contrast, so there's also frontogenetic forcing that's already begun to set up down to the south here. And we'll see at mid-levels, when we look at the 850 millibar and 700 millibar map, you'll also see some confluent frontogenesis already setting up. And that's going to help to accentuate the precipitation as the moisture moves northward into this zone of confluence. We're going to see assets and see some precipitation. Not many stations on this map reporting precip here. We saw it on the radar. The dew point depressions are certainly small enough for it to reach there. It may be just between stations. Further to the north, over parts of southern Minnesota, we see a little bit of light snow. Now that's broken out. And I imagine there are other stations that we look at some of the more close-up maps to perhaps see that. But this is a nice cyclone beginning to form here. Over parts of Kansas and southern, just south of Lincoln, Nebraska, you can make out a minimum and sea level pressure, 994.8 here, 996.7. So perhaps in northern Kansas is where the cyclone exists right now. Perhaps nice warm front that extends out to the east of it. And you can see over the parts of New Mexico and Texas, there's these westerly winds coming off the plateau, just dry air that's being ejected off of that. So this is really a good situation for a cyclone to begin developing. Sounds like there's another trough and wind shift also back over southeastern Colorado. Okay, let's next go to the 250 millibar analysis. And as we talked about in some of the 751, 452, we saw on the satellite image a nice baroclinic leaf cloud with that nice sharp edge. And typically, these aren't isotropic analyses, that might be something we want to think about maybe for next semester to begin putting those together and plotting them. But in a storm relative sense or a system relative sense, those sharp edges that you see in an isotropic chart are going to be associated with a region of confluence along that isotropic layer. And often it's going to be near the region of maximum wind on that isotropic layer. This is an isobaric analysis, but we're pretty far up atmosphere, but that baroclinic leaf cloud we saw probably kind of maps out nicely the axis of it, right along the axis of this isotropic maximum. So a nice, strong, deep trough that's over the western United States. Nice configuration, changing so-called curvature of the flow relative to the Earth. At the base of this trough, the downstream ridge, broad area of ascent we might diagnose or suggested here in this region of divergence that will be over this morning at 12 over parts of Nebraska. Remember, we saw the surface cyclone at this time roughly to the east of it. So this is a pretty favorable configuration for development. Let's go to 500 millibars. And on this chart, again, the trough is a little bit to the north. We see some cold advection, 500 millibars at the base of this trough. Upstream of it is actually warm advection, so this isn't a situation where we'd expect the upper fold to begin developing. But with cold advection at the base of this trough, we'd expect height to begin to fall east of this trough axis at this point. Again, looking at the curvature here, there isn't really much change. You go from cyclonically curved into straight. So this isn't a particularly vigorous upper trough to produce significant. It's not something you would normally just look at and get particularly excited about in terms of forcing for vertical motion, at least at this level. If we go to 700 millibars, things get a bit more interesting. If there are questions or comments, please. This is supposed to be a discussion. We have this broad southwesterly flow that is confluent with this more westerly flow at our latitude. And so that's going to be associated with frontogenesis. And so this is a region, once we get sufficient moisture advected, significant water vapor advected up to this latitude, and can get processed by a developing frontal circulation, we can expect to see precipitation begin to break out in this band. Again, confluent frontogenesis, you can see temperature structure here. Again, nice, very evident region of confluence. That puts us in a nice spot for precipitation along this front. Diagnosing where the axis of dilatation is for this particular flow is probably going to be just a little bit to our north. And so that rising air is going to probably, most of the frontogenesis is going to be just to our north with this precipitation, or with this circulation. 850 millibars, please see, you can see the setup there. Really strong low-level winds, strong low-level warm advection in this region. Tight thermal gradient earlier this morning in western Kansas, eastern Colorado. Significant vertical motion that will be expected here, diagnosed from just the QG omega equation. You can also see, because of the sort of jet-like structure here, you might expect to see QS convergence here. Again, this is just a nice area for significant vertical motion earlier this morning. And so that second area of precipitation that we saw down in the southeastern United States, or the south central part of the United States, is probably linked in with this particular feature. But as this air moves northward, again, you can see this confluent flow exists, right? Strong west to northwesterly flow here, southeasterly flow here. So this is going to be bringing these isotopes together, frontogenic circulation, we expect ascent on this particular, in the upper Midwest later today. I do want to point out there was a really nice storm out in just south of Greenland, the Labrador Sea. Talking to John Martin about it earlier this morning. I haven't looked at it much, but you can see it's a pretty decent, intense cyclone out there, and that might be something that's worthy of looking at another time. Okay, let's get into the forecast. Steve will go first to our MM5 simulation. Next tab, the second tab. So this is for Madison. Again, the trend in temperature, mild, temperature's actually going up until about midnight tonight, and then it kind of bottom falls out of them tomorrow during the day. It's going to be pretty cold, and then we actually recover by the time we move into the Sunday. So we're actually going to begin warming up again. For the precipitation, the bulk of it occurs by midnight, and things drop off a little bit. And there's a second maximum of precipitation that is expected to occur sometime during tomorrow morning before things taper off in the afternoon. So we kind of got the setup for this. 2 periods of precipitation. And the first part will be associated with this Genesis band that sets up to our north and just over us. The second will be with the passage of the cyclone later on. Time height section. On the time height section coming up next, we're going to see the approach of the dynamical tropopause as it lowers over us. Here's the first sort of surge of vertical motion. Actually, supposedly happened earlier this morning, but later on this afternoon is when we get this big surge. You can see the wind varying with height nicely. There's a strong warm advection occurring. You can see the isotropes blowing downward in response or associated with that strong warm advection. We get warming in the mid-troposphere. Localized along the front, we're getting this huge surge of vertical motion. Then we get into this period where things actually the relative humidities begin to drop off. And precipitation, you saw, died off for a little bit. Then a second surge of vertical motion with the approach of this upper trough. As that upper trough is approaching, remember at 6Z is when we saw the temperatures begin to fall. Notice the winds shift, and we begin getting backing with height. And so you can see these isotropes now beginning to rapidly, steeply climb as the cold advection comes in and the dynamical tropopause gets lower. So this is this very vigorous upper trough that's going to go by. And as it passes, we get this big period of significant ascent. And the humidities climb back up and we get the precipitation. And then beyond that, the trough moves out and we get significant warm advection occurring after that. And our warm-up, it'll be a long, slow climb. Just temporarily chilly, and then things begin to warm up significantly as we move into the middle of next week. Let's look at a few different depictions of the surface map from the MM5, and then we'll also look at ECWF and the GFS to get a sense of the evolution of the forecast. We'll start off at the initial time, and this is a pretty decent job. The cyclone is actually a little bit more intense. We saw the surface analysis at 18Z, with a low located a little bit further north than it is depicted right here. The light area precipitation that we saw on the radar over in the warm sector, and that band of precipitation to the north associated with some Genesis as well. Let's go to the next time, please. Let's go actually, next time means nothing. Let's go to 18 hours of forecast of midnight tonight. That cyclone is expected to deepen and move northeast. So position just southeast of us, according to this MM5 forecast. The liquid equivalents for precipitation are pretty intense, with over an inch to the east of the cyclone center of Lake Michigan, and this band of moderate precipitation and liquid equivalent to our north, from the Dells or so, just south of Minneapolis, and then back into eastern Nebraska, north of Omaha City, to Omaha. And you'll also see this sort of depiction, there's no precipitation here, it's not really a dry spot, but you can see in other depictions there's this dry air that begins to come in to the southwest of the cyclone, so cut things off briefly. This structure that we see here is something that John Martin has done a lot of work on, we'll see that it's better depicted when we look at some other maps from the GFS, but it's a trowel-like structure. People sometimes refer to this as wraparound precipitation, but we'll see that it's defined as this ridge of high theta E air that is located, starts off the eastern side of the cyclone, kind of finds itself wrapping around to the north of the cyclone. And within that trowel, this trough of warm air aloft, that's a region where you can see sort of intense precipitation bands set up. And we'll see that it kind of shows up as a pretty decent trowel in the theta E analysis, or diagnosis from the GFS. So that hook-like structure there is something we'll look at some evidence for why we see vertical motion there, as well as the precipitation structure associated with it. Let's go ahead to 12Z tomorrow, so just a few steps ahead, 24 hours in the forecast. That cyclone deepens a little bit more. It moves out of southeastern Wisconsin into northern Michigan pretty rapidly. But you'll notice that there is this broad area of cyclonic circulation, and many of the models have a depiction of a spread in this region And Kari is going to show us some work that she's been doing with singular vectors, which are perturbations you can create from a single forecast trajectory to understand the uncertainties in the forecast. We'll see some evidence of where's the great degree of certainty for the deepening of the storm, as well as maybe the placement of the center of the storm. But in any case, precipitation, another period of moderate precipitation is going to exist, mostly to our north by tomorrow morning. And if we go ahead one more, let's go to 18D. Cyclones, further deepening. The upper trough is, by this time, or the trough, at least in terms of thickness, is right over us. And the last bits of precipitation are just about over for us. But you can see already on this map, this very brief period of cold advection. By the time you get up there, if you go just to our west, the western Iowa and western Minnesota, we already have strong westerly winds, high values of thickness out to the west, warm advection already being spread across the northern plain states toward the Midwest. So this is going to be a short-lived event with snow, and let's now dive a little bit deeper into this to understand what's happening. To do that, I have a terminal open at the bottom. And what it's going to show, we'll step through this. On the left panel, I have theta E, as well as Q vectors, and vertical motion, just the positized vertical motion. On the right, I have the sea level pressure, as well as accumulated precipitation in 3-hour increments. The contour levels are 0.1, let's see, 0.01, 0.1, 0.25, and half an inch liquid equivalent in this. And so if we step forward, this is 18 hours, this will be at midnight tonight. A broad area of cyclonic circulation over us is one absolute minimum, I guess. It's maybe somewhere, it's actually not a minimum. The minimum is maybe back here over northern Illinois. If we go ahead to 21 hours of the forecast, so this is by 3 a.m. tomorrow, the cyclone center is right there in southeastern Wisconsin with the precipitation. And at this time, if you look carefully at the theta E analysis, the theta E in the forecast, you can see this region of sort of a ridge in theta E that is located to the northwest of the storm. Right? Cyclone center is located right here. You see this trough of warm air aloft, which is a ridge in theta E that extends back across the storm. Vertical motions are kind of accentuated in this region. Here we're getting some frontogenetic vertical motion here. You can see Q vectors directed toward higher values of theta and theta E. But further to the northwest, we see there's significant QS convergence. These Q vectors are generally along isotropes, but there's convergence of these right here, and that's creating vertical motions well back to the west to where the surface cyclone is. If we go ahead one more time step to 12 tomorrow morning. Cyclone moves into Lake Michigan. You can see this trough of warm air aloft that extends back through here and kind of curves back to the southwest. And along it, at sort of the head of it, as well as further to the west, we see this nice region of Q vector convergence and ascent that's located just to our north, and another area that's located right over the Great Lakes. So if we step ahead one more time period, you'll see where those maximum vertical motion were to the saturated, where we're going to get some of the heaviest precipitation at later time periods, for that accumulated precipitation. So we're going to look at the GFS forecast in a moment in terms of how much precip is produced, but before we do that, we'll just move through this one more time to see this structure, the Q vector structure as well. This is actually now frontolytic at this final time. But you do a semicolon S, it'll just move a couple times. S, no, right over there. This is just a brief period from 12 hours of the forecast to 30 hours of the forecast. Just looking at the evolution of the cyclone as it goes by, the precipitation and the northwest winds that come in. And over here are the Q vectors. Q vectors indicate the time rate of change of the vector gradient of potential temperature. And you can see how they're aligned to the theta E is in the purple contours. And we can sort of see that thermal ridge develop. and then move off to the northeast fairly quickly. Just one way to diagnose the ascent in this case. We can click on that and stop it and go back to the MM5 forecast. A couple things I want to point out. If we go to the 700 millibar relative humidity and look at index at 24 hours, again, this notch, this is very stable air and dry air that's come in. Our surface cyclone was located to the east here, but you can see this relative humidity maximum, which is partly consistent with that beta E ridge that we saw that was hanging back to the northwest of the storm, but also this dry air that's been coming and briefly cut off our precipitation. These dry slots have their origins as air that starts off ahead of the upper trough, or upstream of the upper trough in the lower stratosphere as a modest or even intense mid-level circulation begins to develop. That air as it's descending behind the upper trough where we typically see ascent, gets caught in that cyclonic circulation and then gets wrapped around it. So the upper trough is back through here, the surface cyclone is here, this is the dry air that has its origins in the troposphere, so some of that's appearing in this cross-section, or this map at this particular time. And very stable air here as well. The air ahead of this front and ahead of the cyclone is both moist, you can see the high relative humidities, but also with negative lifted indices, so it's pretty unstable as air rises, so there's plenty of convection that breaks out ahead of this line as well with this particular cyclone.
There's a fair tornado threat of that too. We'll go to SPC, that's the other thing to take a look at. The last thing I want to do is just kind of zoom into the, I don't know if we can bring this FLI up, if it will work, or we can just do the GIF, but we can't control the speed of it. I don't think I have anything to show FLIs anymore. Okay, so this just shows the progression of the precipitation. This is a loop every 3 hours. Maybe we'll actually just step through a couple quick. We'll go to 12 hours of forecast. So you can see, again, really it nicely depicts strong warm advection to the south, strong east winds here, so we have frontogenesis along this band. North of it, we have the warm air rising, the semi direct circulation, and that's producing the precipitation north of the surface front. A nice band of precipitation. Here in Madison, the temperatures at the surface are +2. We're going to be probably in the mid-30s when this comes in. That's going to be predominantly rain. And then there's this other band of precipitation from Baltimore north that will be cold enough for it to be coming in as frozen precipitation. Let's go ahead just 3 hours to 15 hours of forecast, 9 o'clock tonight. And here's 2 degree Celsius isotherms come down a little bit, but again, we still see this really strong warm advection to the south, and then it just sort of cuts off with these east winds. This is a nice frontogenetic band precipitation right over us. Cyclone center, you can kind of make it out in east central Iowa. And we'll go ahead 3 hours again, and we'll see the beginning of the cold advection coming in by the time we get to midnight. Winds by midnight should have switched over to the north. We're still above freezing, so this is all liquid precipitation, but I imagine areas to our west might be concerned about icing beginning to develop on roads and on surfaces well to the northwest of us. But the heavy precipitation and the deeper cold air is continuing nicely in the northwestern part of our state. And we'll go ahead to tomorrow morning. We'll go to 24 hours. Cold air is firmly entrenched here with northerly winds, northwesterly winds, and here's that second bout of precipitation. And here's that dry spot where things are going to cut off for a bit. And here comes the next round of precipitation. So that looks pretty good. All right. So we're going to quit this and go to the next tab, please. The first one, this is the ECWF solution for this, giving us 1.9 inches of precipitation here. Again, this broad band of precipitation amounts close to 10 inches in the center of it, just south of the Twin Cities. And another local band of precipitation from just northwest of Green Bay to the central part of the state. Maybe near Wausau, that's going to be also close to 10 inches. This is again valid by 20 tomorrow afternoon. Let's go and just look at slowly step through, go to surface of precip, and we'll look at the surface map. We'll go back to, let's go to midnight, 18 hours of forecast. You get a sense of what's happening.
In this forecast, they have this broad area of cyclonic circulation located over the southeastern part of our state, from Lake Michigan all the way back to southeastern Iowa. And again, they have that break in precipitation. This all looks very convective in my eye, but then the heavy snow or moderate heavy snow well to the northwest of the cyclone. So you step ahead till to 21 degrees, so 3 a.m. in the morning. The main low is now moved into Michigan, but we still have this broad cyclonic circulation, but it's not just where the surface low is. If we could take this data and look at the theta E, we would see this trough of warm air loft mix that wraps around the cyclone, at least the trough right here, well to the west of us. And so we're getting heavy precipitation, heavy snowfall beginning to break out around the La Crosse area, the local La Crosse area. Let's go ahead another 3 hours by tomorrow morning, 12Z. In this forecast, as that line of the precipitation, the change line from rain to snow or whatever the mix is, arriving in Madison and Dane County by early tomorrow morning. So this forecast suggests that these would be a period of pretty decent snowfall rates arriving sometime around daybreak, 6 a.m. or so. Again, the work model, not the work, the GFF. The MM5 also had, again, a second maximum precipitation during that time period. And notice the surface cyclone we saw here is kind of, it's not identified as a minimum right here, the kind of low is toward the Great Lakes area. It hasn't backed up or anything, it's just where the minimum of here is this particular time. And there's that convective precipitation, whose cellular convection off the lawn ahead of the cold front. And one more 3-hour jump. Freeze finally begins to dissipate as the cyclone moves away into northern Michigan. One final look at this, if we go to 12Z, we'll click on 12Z, so 24-hour forecast. Sorry, the 24-hour forecast. We'll go up here to single image, and we'll look at model comparison. And we can kind of run across the top with all the models that are available at the same time to get a sense of what's expected. So this is the ECWF model, the next is the Canadian model, which also depicts that transition to snow, but the snowfall rates are a little bit weaker here. The GFS at the same time actually has, pretty good snowfall rates in the central part of the state at this point, below over eastern Lake Michigan. The HER, it was transitioning with maybe light to moderate snowfall at this point. North HRW is a little bit lighter. And we can run across this and see the variety of solutions. This has most of the precipitation occurring well to our northwest. We can just keep moving across the board to see this. So precipitation amounts are again, there's a good chance that tomorrow morning it will look pretty decent with the snowfall coming down. How much we ultimately get is going to be another question. So if we scroll to the bottom, look at the winter weather tab, and look at winter last tab at the very bottom, and look at total snow accumulation. These are all valid at the same time. So even though we get that nice burst of snow in the ECWF model, we only get 0.7 inches of, actually let's go ahead and
That's only at 24 hours.
Yeah, let's just go to 33 hours in this. So we can just go right across because it's just about over by 12 anyway. So 1.9. Don't put GFS in. Oh, that's nice. All right, there you go.
I'm going to go to 36.
I don't think it's going to change much.
I thought there were more models available.
Oh, okay. So 1.9, 1.1, 1.9, so on. Curves, about an inch. 1.9, 1.5. Look at an inch or two perhaps for snowfall. Now a little bit less than that. This is a blend of models. I'm not sure how they do the blend, but about an inch or so. So maybe a conservative forecast would be anywhere from half an inch to a couple inches of snowfall over Dane County, but significantly more. These purples are where you get to 6 inches or more are going to be well to our northwest, north of the Dells probably. So before going on to look at the warm-up and some of the implications of having snowfall here, Carrie, would you like to show some of the work we have in the singular vector?
Yeah, I sent you an email with the results. I sent you an email.
Oh. That was a good email on this. Yeah, it was.
Mute that screen.
Yeah. Gotta figure out how to get this. I don't use webmail things as particularly.
Should also look at the SDC with a moderate risk, 15% hatch for tornadoes.
Here it goes. Make sure this works. You wanna, Carrie, you wanna come and talk about it?
I don't know why the video looks too small for it.
It's because we're showing it in Linux and LibreOffice. This is not PowerPoint.
But hold on, let me go back to, is this the first slide?
Yes, that's the first slide.
Okay. So you're gonna introduce what this is from?
So, the way that we did this kind of plot, we use the singular vector, which is a technique to calculate or estimate the optimal perturbation in, or the large amplitude of perturbation in the area. So we use the initial time from last night, no, from this morning, from December at 12 UTC to December 11, 12 UTC, so for 24 hours. So we run this single vector, we calculate single vector for 24 hours to estimate the perturbations they're going to produce a larger spread in the forecast 24 hours later. So, so here we are plotting just the sea level pressure just to see the probability of the sea level pressure for the next 24 hours. So what is this is showing, we have the sea level pressure for 95 millibars. So the probability to have a sea level pressure less than that is start increasing with time as the storm or the winter storm start moving close to Wisconsin, or moving to the north, and we're seeing here. So the area is increasing, the probability to have a storm or a sea level pressure less than 95 millibars increased by the final time that we are observing here. So in the next slide, we
Okay.
yes.
I'm gonna add a couple things. So yeah, so this is an ensemble that has how many members?
5 ensemble members. We have the control front, and we have 4 ensemble members that were produced by the singular vector calculation.
Okay, so it's 4 plus and 4 minus, or?
The one perturbation, we have the positive perturbation and negative perturbation, and the second perturbation the same. So yeah, so in total 4.
So total of how many ensemble members, sorry?
5 ensemble
ensemble
members.
members,
5
okay.
ensemble members.
And so based on those ensemble members, we can come up with a just a very crude estimate for the forecast. Well, what's the probability that anywhere on this map we'll see sea level pressures less than 995 hectopascal? And the big point on this is, obviously, there's a lot of consistency that there's going to be a storm emerging over Kansas and moving northeastward and deepening, and it's likely it's going to be sub 995. That's just an example of how we might use this tool.
So in the next slide, we are showing probably the same. So we decrease the sea level pressure, and we keep observing the same, but obviously the area is smaller. But still, we have seen a deepening of the winter storm over the area here in the north. Okay. So,
Yep.
On the panels H and I, does the large distribution denote a stronger, larger storm or a spread in the forecast? Like where the cyclone center is. So for like panel I, does that indicate that there's a broader area that's all inclusive, across all 5 ensemble members that's below 990?
yeah, that's the
Or-
probability that among all the ensemble members to have a higher, or the probability is like 90% to have a cellular pressure less than 90. But it's among all the ensemble members. Yeah.
And also it's, okay, I think you have an isobar, a map of the isobar.
Yes,
Okay.
that's included. I think that's the next slide.
Brad's got a
There's
question.
a
Oh, question, Brad.
So this is showing probability, not uncertainty, right? It's just
Yeah,
here's the
probability.
likelihood. It's not really the spread, it's the likelihood.
Right, this is just the likelihood. We do have some standard deviation maps that will show that in a moment. And again, this is the technique, it's exactly the same technique that UW-AOS uses to do their ensemble forecast for their, for the UW-AOS model. They use this ensemble technique with some other bells and whistles added. This is just using the WARF model. And the one thing I'll note, the first time anyone in the world has done this with a WARF model, calculating singular vectors, and you're seeing some of the first output from a real-time run, or near real-time run that we've done on this.
But I may be anticipating the next slide, that you do the same thing for probability of precipitation?
I think
No, I didn't get the probability for precipitation, but I did the average and the standard deviation for the combination of precipitation for 24 hours.
Right.
But yeah, that's something that maybe I should include.
right. It's like the probability exceeds a certain threshold.
Right, that would be great.
Yeah, that's something
Yeah.
we're working on. So,
So yeah, I know it looks small, sorry about that, but what we're seeing here is the standard deviation of the cellular pressure. So we're starting seeing that the variance of the cellular pressure starting increasing as this storm is moving through the north. So
right, so a couple of things to note about this. So this is indicating these, again, the variance in sea level pressure. And you might say, well, does it mean there are 2 cyclones there? And I don't think that's the case. I think this is more the cold air that's surging behind the southwest of the cyclone and the hydrostatic response to that. It could be just the placement of where the cold air is hydrostatically. But the northern one, I think, indicates, I'm sorry, I was excited about seeing this. The northern one is indicating maybe on the western edge of that cyclone as it's developing, is there more of a trough that's hanging back or not? Okay.
yeah, I think the next slide is the same, but with different color parts, so we can skip that one. It's
Okay.
just showing the
So it's
same
the same thing,
spread,
okay.
yeah. So here is the 0-degree isoline. So here we have the initial time and the final time. I'm not 100% sure why we have that kind of
That's
spread like
correct.
that in the final, in the initial time. Yeah, maybe I should look from the script again. But where we're seeing here that there seems to be very consistent in the spread of the with this isoline. Although we are seeing a slightly spread here, so that indicates that the variability to have the 0 degrees over in that region, so that indicates that will happen spread in the amount of precipitation. that we
Right, so
get
this
here.
is 12 tomorrow morning, right?
Yeah, this is the final time, so that will be 12 tomorrow morning, yeah.
So yeah, so this could be, this might be a useful product if someone's interested in road icing, or is there going to be likelihood of icing, given that we're going to be pretty close to, you can see southeastern Wisconsin is pretty close to freezing. This gives us some idea of the spread, in this case, of the 0-degree isotherm. And you can see it's pretty tightly packed for many of the ensemble members.
I forgot to include the level, but this is 900 hectopascal, so it's very close to the surface, so yeah, we are seeing that kind of spread. So that's why it's important to know in which area. Yes, what are the colors? So the dashed line means negative when we add negative perturbation to the model or to the control forecast, and the solid line are when we add positive. Sorry, it's like the same. Solid line when we add positive when we add perturbations, and dashed line when we subtract perturbations from the control forecast.
And the colors are different ensemble
Yeah.
members. And I think this contour over here is probably
Yeah, we
supposed to
have
be
the
over there.
dash here and the solid line kind of over here, but there seems to be kind of overlapping here.
The color may not be distinct.
Which level is it?
The what?
Which level?
900. Yeah, it's very close to the surface. So here you're seeing the temperature, the average in temperature, and the standard deviation. So this may explain this also when we observe the sea level pressure standard deviation or the variance. We have the same over there, same region actually. So we are seeing an increase in variance over here, about 3 degrees in Illinois. So yeah, I think.
So that map goes, this is at 900 as well?
It should be 9, yes, I'm 100%.
Okay. And so I think it compares nicely with this one, which is, I mean, it's the same, it's from the same data. That spread you see over Illinois
Yeah,
is
we are seeing
consistent.
over here.
Yeah, it's consistent with what you're seeing there.
Yeah.
But this is for all, not just one isotherm, it's for the whole temperature. Any other, questions, comments, or do you have others? I haven't looked at the
I
deck
think I
yet.
have more slides.
Okay.
Yeah, I think, yeah. So this is the isomer for that specific millibar. So we are seeing the system is intensifying over this region. This is the final time. But we compare with different isobars at the same final time. We are observing that the spread among all ensemble members start increasing, but it start reducing in area. So that means that it's weakening over time. So this is what we're observing here. We decrease the isobar to 991. And we are seeing that the areas is decreasing, so that means that the cyclone is weakening. Yes.
Yeah, it's not so much weakening, but what this does show is that at this contour level, oops, let me go back. All this, just about all the ensemble members have a similar intensity, at least within the 995 contour. But when we begin to see greater spread or greater area covered by these particular isobars, that's an indication that some cyclones are weaker, the ones that have a smaller contour, and the larger contours, the 991 that are bigger, indicate perhaps a stronger cyclone.
And the dash are from the negative perturbation?
Right.
Yes.
And negative perturb doesn't mean it necessarily has to be weaker or stronger, it's just adding or subtracting the
But it does say
perturbation.
there's probably not a lot of air in position.
That's right. Exactly right. As Brad was saying, for this here, it suggests that there's not much air in position for the cyclone.
So we observe the same with a different isobar over the same time region.
And then there's-
And I think that's the last slide.
Okay. And just, the final point on here, you can see this is the 987 contour. You can see that small red contour over northern Michigan, it's from at valid at the same time as all the other ones, which are much larger. So there's at least one ensemble member that's much weaker that has the cyclone centered over northern Michigan. But again, the track is about the same. So again, these are early, hot off the press results, but Terry's been working hard on this project for the last year or so, and we're now beginning to develop some possible products from this, and we're going to try to operationalize this as well.
I have a
Great.
comment. I think this is really, really exciting, and I think, this is the warn-on forecast. This is what you need so that you can say, let's use these forecasts to warn for,
Whatever the hazard is.
It'd be interesting, again, to look at probability of precipitation, look at date, look at significance. If you can do the same thing with a lot of other variables, then this is exactly where the National Weather Service wants to go.
Okay. Thanks, well, Terry. Other questions?
Yeah, sorry. Going to the very first slide.
The probability?
Yeah, the probability slide.
I think, yeah.
Yeah, are these probabilities like continuous or is it discrete based on a number of members that were in that level? Does that make sense?
Yeah, so this is really a frequency based on the 5 ensemble members. We could have 25, and this was just again a quick run and demonstration of the idea, but it's really a frequency plot. How many members at this grid point at suitable pressures below a certain value? Uncalibrated, there's nothing fancy that's been done with that aspect of it yet. Yeah, please.
For these plots, instead of looking for a pressure threshold on this slide, you have 995, would you be able to do a rate of change of your pressure? So you can set a threshold for
The change, you said?
So use like 5 millibars for 3 hours.
Yeah. I think it's possible to do that, yeah.
I imagine you could do something similar for maybe temperature as well, if you're looking for changes in precipitation type associated with freezing rain type of conditions that you want to forecast.
No, that's an excellent idea. So, as Terry said, we can do the time rate of change of pressure, whatever the variable is. That's doable. And then, if we're looking at freezing rain or some other variables, we could do that as well.
I was just gonna ask, I guess, if I understand this correctly, on the next slide, there's strong standard deviation, or sorry, one more. In this loop, there's strong standard deviations along the cold front in the sea level pressure field, increasing in time. Do you think that's consistent with the current genesis we see? If I increase the strength of the thermal gradient, I increase the cyclonic vorticity at the lowest levels, and I need to drive, so if I have strong spread in my thermal gradient in that region, I'll see strong spread in my low level cyclonic circulation as well.
Sorry.
I would say it's possible, but I made a comment earlier that I thought this might be just sea level pressure, but I hadn't seen all these slides, but if you recall, the biggest spread in the temperature was up here in Illinois.
Right.
And it's down here where we're seeing this other feature. And we'd have to dive more into the data, look at the individual maps that make this up to get a sense of what that's all about. Because it could be just slowness in the progression of a trough or something, and maybe not fully just the frontal position.
I think there was some spread back into Oklahoma though, on the southwest end of that for those isotherms.
Yeah, I almost wonder, like, if the individual isotherm, just knowing the one doesn't tell you about the strength of the gradient in the area. You're only looking
That's
at
true.
one isotherm.
Right. Yeah, this is not doing that. That's just taking temperature, no pressure. Yeah, pressure.
This is better pressure.
Right.
Yeah.
I think we did see that spread, or at least I noticed when we were looking at other models comparison, the orientation of the cold front seemed to be tilting in a slightly different angle comparing in the geographic WRC. This looks like consistent results. Uncertainty of the orientation of the cold front of Illinois.
So, and just a couple other comments about this. The way this is developed is trying to maximize the, I'll put in quotes, energy associated with differences from the control forecast and the UV, we have W in there? UV theta
UV, theta, and mu.
and mu, which is a measure of the dry air mass at the bottom of the column. It doesn't include moisture as one of the variables, but that could also be included as well. And we're just trying to, so what structure at the initial time could we perturb the model by to get the maximum spread in the forecast as measured by this energy at the final time? And it's an eigenvalue problem, and it's solved multiple times, a lot of iterations that go on, but it then produces, in this case, you did, how many iterations, 25?
Just 25, and we got only 4 not for single values, so that means in total we will have like 8 or 9 symbol members, so we can increase the symbol members for adding 4 more. So
Yeah, so the number of ensemble members is just limited by the computer resources we have. This is on a 90-kilometer grid, so there are other things we can do to refine this. But again, early stages, but I think really exciting work. And thanks for the comments and suggestions. We'll see more of this next semester. Okay, so we'll go back. Thank you, Karen. And just finish off with the, just quickly looking at the warmth at the end of the week, the final tab. Not final tab, the tab before it, or one of these two tabs. Yeah. So this is the forecast for 6Z, so midnight Thursday. And what we can see is, here in Madison, the temperature of 65 degrees here, just absolutely incredibly warm. And we'll look at the bigger map picture, but one of the things I wanted to show here was really, it's interesting, this strong gradient. If we take this time and go to this, just quickly go down to the winter weather snowfall depth, it's going to be pretty close to where the snow has been or had been melting, right? So how much snow we get to the north here is going to play a big role in where that strong temperature gradient is going to be. One of the things that I'm thinking about is for this winter storm that's coming up tomorrow, if the snowfall extends a little bit further south than the models are forecasting, that can have a big impact on how much we warm up. Because if we have that surge of warm induction during the day on Thursday, so later next week, that's going to be frontogenetical right along that boundary. And that boundary is going to be tough to move to the north. So that could mean lots of clouds, just kind of a gloomy day, and not getting significantly warm. So that's something to watch. How far north? You don't have to have snow on the ground here, but if it's nearby, that gradient, that could really stall the motion, the forward motion of this warm front going far to the north. So something to look at. So let's go back and look at the national map.
Just to give you a perspective on those temperatures,
Yeah.
remember you had a 65 at midnight in Madison? Patrick Beatty was watching online, said the all-time, let's see, the record high for Wednesday is 52. The all-time December high temperature record for Madison is 65. So if we had a low temperature of 65, or not a low, but a temperature of 65 at midnight, that would be equal to the all-time maximum temperature in December.
In December. So this is record, which is just nutty. So let's not have the snow. I know John's watching. John, no snow. We want to warm up.
He said he record high on Thursday is 57, by the way. So
We'll certainly break those. Let's go to the national map quickly, and then we'll just look at the nation, see the evolution of this. We warmed up. So go sea level pressure, surface precip, second break, and then here, let's let it run. We watch the evolution of the cyclone, but also, yeah, so here goes our cyclone, there's the snow. Here comes the warm advection, the warm up. Pretty much it's all week. We're at 78 hours in the forecast. It's now Tuesday, Wednesday. Look at these thicknesses, almost spring-like. But notice we had a precip to the north before this, everything collapses again. And that's where that frontogenesis and just the really warm, moist air went over that cool, snow-covered ground or chilly ground to the north as we get some precip. And then we get back into more of a winter-like pattern after that. So we just bring this back a little bit to 126 hours or so. Stop the animation. Right. That's going to be a tough way to review this. But you can see again, the warm advection sets up. This is on today, Wednesday, and we'll certainly have a nice day on Wednesday. Then keep going forward. Nice warm advection. You can begin to get that precip breaking out of the northern part of this, which might be associated with some weak frontogenesis in the lower troposphere. This is Thursday evening, or Thursday morning actually still, so this is after that warm period. We'll eke out probably part of the early morning still being warm, and then we got a cold front that comes through and the temperature just crash back down to normal or below, certainly below normal after. If we go to the very end of this, we can just click on 384. Actually, 372. What is that? 360. Sorry. For those of you who like snow on the ground on Christmas morning or snow, that's the forecast at this point. Again, this is so far out, it's almost embarrassing to show it, but there may be a possibility of some light snow on Christmas. And we can, since it's not all the way at the end of the forecast period, we can go to the 0 hour forecast to see what that looks like. Cold, maybe still possible there's some snow, I think. In any case, this is the last weather watch of the semester, and I'd like to thank everyone that's been coming here, both regularly or just when you've had the time to come, and folks that have engaged in the discussions. Greg, Pete, Brad, students here. I thank Kari today for showing some of the work that she's been doing. And I forgot, we do have the Sdc Outlook, and as Zoe was mentioning, moderate risk of severe weather, I think it's tornadoes.
Yeah.
That's categorical, it is tornadoes.
Yeah, tornadoes. And then what about wind, gales? So this is going to be a really active weather system. And it might even be possible, I mean, to the extent that you can take some of the variables for an ensemble. In fact, it's not even possible if people are doing it. Taking ensembles and using the output of that to come up with features like that, but that takes a long historical data set to begin coming up with these probabilities. But I'm kind of thinking back to what Kari was just showing us. But this is really, got a really active cyclone moving through the Midwest, and then the southeastern part of the United States has a chance for some severe weather tomorrow. So I'll start with that.
Some of the conversation around that is also the timing of severe weather is likely going to be overnight, and just thinking about more social science, this communication, that's always a really good setup because people can't see and aren't awake or aware overnight.
That's right. So Zoe was saying, the timing when this occurs, will people, one, even be attuned to it? They say, December, severe weather, not even thinking about it perhaps. But that second level is it's happening at night. We're not going to, may not be attuned to it. So lots of issues, as always pointed out, that are going to be important for people to understand. It's not just getting the great forecast out, it's how you communicate it and how you get people to take action on it. And that's what the Weather Service is spending a lot of time thinking about.
It's pretty unusual. It's probably almost as unusual to have a moderate risk like this time of year, as it is for us to get that warm weather. And it's going to be a hard time getting people to notice that they're under a high risk at this time of year.
Yep. Well, thanks for the comments on the severe weather part of this, and thanks for your attention.
Thanks, Michael, for leading through this semester.
John will be back, and we'll have John, Greg, and I will be fully engaged in the conversations we've had in the past on weather next spring, so that'll be exciting. Okay, thanks, everyone. Have a wonderful week and break.
With those spaghetti